Hello everyone. Here we are going to see Unit 18 Critical Path Method. So structure of this unit is objectives, basic terminologies in CPM. CPM means Critical Path Method. Next one is solved examples, sum up, keywords and some terminal questions have been given for you. Okay, first one is objective of this unit. After reading this unit, you should be able to understand the definitions of critical path and critical activities and to determine the project completion time for a network or project. Okay, some basic terminologies in CPM. So, the critical path method aims at the determination of the time to complete a project and the important activities on which a manager shall focus attention. That is, the CPM aims at the determination of the time to complete a project and the important activities on which a manager shall focus attention. First thing is project completion time for the start event to from the start event to the end event, the time required to complete all the activities of the project in the specified sequence. That is what a project completion time. Okay, so we have to start from the start event to the end event. The time required to complete all the activities of the project in the specified sequence. That is what a project completion time. Then path in a project. It is a continuous sequence consisting of nodes and activities and beginning with the start event and stopping at the end event. That is what a path. Okay. Then critical path and critical activities. Critical path and critical activities. So the path with the largest time duration. The path with the largest time duration value is called the critical path, and the activities along this path are called the critical activities, and it is also known as bottleneck activities. Yes, so let us consider all the parts in a project beginning with the start event and stopping at the end event. For each path, calculate the time of execution by adding the time for the individual activities in that path. Okay, so the path with the largest time is called the critical path, and the activities along this path are called critical activities or bottleneck activities. Okay, so you have to know the definition for CPM. So CPM is nothing but a critical path method, and it is a statistical tool used for scheduling project activities, and it funds the maximum time required for the completion of a specific task. The completion of a specific task. And some of the uses of CPM are it is useful for construction projects that are predictable and certain. Okay, and one more thing you have to know, that is assumptions. Some assumptions are there for CPM. Okay, so the first assumption for CPM is project activities can be identified as entities. Project activities can be identified as entities. That is, there is a clear beginning and ending point for each activity. That is what project activities can be identified as entities. Okay. So next assumption for CPM is a project activity sequence relationship can be specified and networked. Project activity sequence relationships can be specified and networked. And the third assumption for CPM is the activity times follow the beta distribution. with the variance of the project assumed to equal the sum of the variance along the critical path. Okay, so the activity times follows the beta distribution with the variance of the project assumed to equal the sum of the variances along the critical path. Along the critical path. Okay, and the last assumption for CPMS, a project control should focus on the critical path. Project control should focus on the critical path. So these are all the assumptions you should know. Okay. Then the next thing is example problems. First problem, see here, the following details are available regarding a project. We have to determine the critical path, the critical activities, and the project completion time by using the given data. Yes. So see here, activity A has no predecessor activity and its time duration value is 3 weeks. Okay, and the first column denotes the activity column and the second column denotes the predecessor activity for the activities, and the third column denotes duration values in weeks. Okay, so what's there in the first row? It is first activity is A. It has no predecessor activity and its time duration value is 3 weeks. 3 weeks. Okay, then second activity is B. Its its predecessor activity is A and its time duration value is 5. Okay, then C is the third activity. Its predecessor activity is also A. Its time duration is 7. Its time duration is 7 weeks. And what's there in the next place? It is D, activity D. Its predecessor activity is B. Its time duration value is 10 weeks. 10 weeks. Okay, then E is the next activity and E has the predecessor activity C and its time duration value is 5 weeks, and the last activity is F. F is the last activity and it has the predecessor activities D and E and its time duration is 4 weeks. 4 weeks. Okay, then determine using these or all these things, we have to determine the critical path, the critical activities, and the project completion time. Project completion time. Okay, so see here. So let us construct the network diagram for the given project. So what's that? We have to start a node from 1 and activity is A. Okay, A has no predecessor activity. A has no predecessor activity. Okay, its time duration value is 3 weeks. So we have to draw a path between 1 and 2. 1 and 2. This is what a path or node. The directed arrow is called path or node. Okay. So we have to draw a path between 1 and 2. Its activity name is A and its time duration value for A is 3 weeks. 3 weeks. Okay. Next thing is 2 to 3. 2 to 3. So draw a path between 2 to 3. Its activity name is B and B has a predecessor activity A. So B has a predecessor activity A. Okay. Okay. Its time duration value is 5. Is 5. Okay, next moving on to C. C has a predecessor activity again A. So we have to draw a path between 2 and 4. 2 and 4. Draw a path between 2 and 4. Its activity name is C and C has a predecessor activity A. Yes, do you understand? C has a predecessor activity A. Its time duration is 7. 7. Okay. Then see here D has the predecessor activity B. So we have to draw a path between 3 and 5. 3 and 5. 3 and 5. Okay. So its activity name is D and D has the predecessor activity B and the time duration for activity D is 10. Is 10. Okay. Next activity is E and E has the predecessor activity C. So we have to draw a path between 4 and 5. 4 and 5. Okay. And its activity name is E. E has the predecessor activity C and its corresponding time duration value is 5. 5. And your last activity is F. F has the predecessor activity D and E. F has the predecessor activity D and E. D and E. Its time duration value is its time duration value is 4. Okay. So now we are going to find the critical path. The critical path. Okay. For that, consider the paths beginning with the start node and stopping with the end node. Okay, there are two such paths for the given project. There are two such paths for the given project. They are path 1 is 1 to 2, 2 to 3, 3 to 5, 5 to 6. And path 2 is 1 to 2, 2 to 4, 4 to 5, 5 to 6. Okay, see here, path 1. Path 1 is 1 to 2, 2 to 3, 3 to 5, and 5 to 6. So 1 to 2 is having an activity A, and 2 to 3 is having an activity B, and 3 to 5 is having an activity D, and 5 to 6 is having an activity F. Okay, then with time, with the time 3 plus 5 plus 10 plus 4, it is 22 weeks. Then path 2, it starts from again first node 1 to 2, 2 to 4, 4 to 5, 5 to 6. So 1 to 2 is having an activity A and 2 to 4 is having an activity C and 4 to 5 is having activity 5 and 5 to 6 is having an activity F. Okay, so the time duration from 1 to 2 is 3. Then time duration for second node to the fourth node is 7, and the time duration for fourth node to the fifth node is 5, and the last thing fifth node to sixth node is 4. So 3 plus 7 plus 5 plus 14, it is 19 weeks. 19 weeks. Okay, so compare the times for these two parts. Maximum of what's the definition for critical path? Critical path, it is the longest time duration value, the largest time duration value. Okay, so we have to find the maximum of 22 and 19. 22, the maximum of these two parts, time value of these two parts, it is 22 and 19. So it is 22. So we see that path 1 has the maximum time of 22 weeks. Therefore, path 1 is the critical path. Path 1 is the critical path. The rest of the the critical activities are A, B, D, and F. Okay, and the project completion time. The project completion time is 22 weeks. 22 weeks. Okay. Here we notice that E and F are non-critical activities. I mean, critical activities are A, B, D, and F. Yes, critical activities are A, B, D, and F. The rest of the activities, C and E are non-critical activities. Non-critical activities. Therefore, time for path 1, the difference between the time for path 1 and the time for path 2 is 22 minus 19. It is 3 weeks. Therefore, together, the non-critical activities can be delayed up to a maximum number of 3 weeks. 3 weeks without delaying the completion of the whole project. Okay. So this is what how to find the critical path and the duration values and the critical activities. Okay. See here, for example, problem number 2. Find out the completion time and the critical activities for the following project. Okay, they have given one network diagram. Yes, they have given one project or network diagram. We are going to use this diagram. We are going to use this diagram. Find out the completion time and critical activities. The completion time and critical activities. Okay. So see here. So we have to identify that how many possible paths, how many possible ways to complete this project. Yes, see here, 1 to 2, 2 to 5, 5 to 8, 8 to 10. Next path is 1 to 3, 3 to 6, 6 to 8, 8 to 10. Next, another possible paths are 1 to 2, 1 to 3, 3 to 6, 6 to 9, 9 to 10. One more possible path is there. It is 1 to 4, 4 to 7, 7 to 9, 9 to 10. 9 to 10. Okay. So, see here, in all the ways we identify 4 different paths, beginning with the start node of 1 and terminating at the n node of 10. Okay, so they are path 1 is 1 to 2, 2 to 5, 5 to 8, 8 to 10. Okay, so activity 1 to 2, node 1 to node 2 is having an activity 8 and its time duration value, its corresponding time duration value is 8. Then from node 2 to node 5 is having an activity D and its corresponding time duration value is 20. Okay, then node 5 to node 8, it is having an activity G and its corresponding time duration value is 8. Okay, then the last thing, 8, from 8 to 10 is having an activity K and its corresponding time duration value is 6. 6. So we have to add all these things. 8 plus 20 plus 8 plus 6. What do you get? It is 42 units of time. 42 units of time. So next thing, path 2. Path 2. So it's also it start from node 1. So 1 to 2, 1 to 3, it is having an activity B and its corresponding time duration value is 10. Then from 3 to 6 is having an activity E. Its corresponding time duration value is 16. Then 6 to 8 is having an activity H and its corresponding time duration value is 11. Then 8 to 10. 8 to 10 is having an activity K and its corresponding time duration value is 6. So we have to sum up all the time duration values. Yes, we have to sum up all the time duration. 10 plus 16 plus 11 plus 6. So what do you get? It is 43 units of time. 43 units of time. Then path 3. Path 3, it is also starts from the node 1. Node 1. So from node 1 to node 3 is having an activity B and its corresponding time duration value is 10. Then from node 3 to node 6 is having an activity E and its corresponding time duration value is 16. Then from node 6 to node 9 is having an activity I and its corresponding time duration value is 14. Then from node 9 to node 10 is there. Its activity name is L and its corresponding time duration value is 5. Value is 5. So we have to add all these things. 10 plus 16 plus 14 plus 5. What do you get? It is 45 units of time. 45 units of time. Okay. Then path 4, it also starts from the node 1. It also starts from the node 1. Yes. What do you get? From node 1 to node 4 is having an activity C and its corresponding time duration value is 7. From node 4 to node 7 is having an activity F and its corresponding time duration value is 25. Then 7 to 9 is having an activity J and its time duration is 10. Then from 9 to 10 is having an activity L and its corresponding time duration value is 5. Okay, so time for the path for this path 4 is 7 plus 25 plus 10 plus 5. It is 47 units of time. 47 units of time. So compare the compare these time estimates. Yes, what's the definition for critical path? It is the longest time duration value. Longest time duration value. So we have to compare the time for all the 4 parts. All the 4 parts. So we have to find maximum of 42, 43, 45, 47. It is 47. 47. That is path 4 has the longest time duration value. Okay. So the critical activities are C, F, J and L. The non-critical activities are rest of these activities. They are A, B, D, E, G, H, I and K. Therefore, the project completion time is 47 units of time. completion of the project completion time is 47 units of time. 47 units of time. Then problem number 3. Draw the network diagram and determine the critical path for the following project. So using these activities and duration time estimate values, we have to draw a project network diagram. And also we have to determine the critical path for that project. Okay. Yes. What's there? So it is the first activity. It is the first activity. What's the first activity? It is 1 to 2. So 1 to 2 is having an activity A and its corresponding time duration is 5. Then second thing is also starts from the node 1. So 1, 2, 3 is there. So we have to draw a path between 1 and 3. Its corresponding activity name is B and its time duration value is 6. Next 1 to 4 is there. 1 to 4. 1 to 4. So we have to draw a path between 1 and 4. Path between 1 and 4. Okay, 1 and 4, and its activity name is C. Its corresponding time duration is 3. Then 2 to 5 is there. Draw a path between 2 and 5, second node and the fifth node. Okay, its activity name is D and its corresponding time duration value is 5. 5. Okay, then next thing is the 3 to 6 is there. 3 to 6. So draw a path between 3 and 6. 3 and 6. Its activity name is E and its corresponding time duration value is 7. Then 3 to 7 is there. So draw a path between 3 and 7. Its activity name is F and corresponding time duration value is 10. Then draw a path between 4 and 7. 4 and 7. Its activity name is G and its corresponding time duration value is 4. Okay. Then draw a path between 5 and 8. 5 and 8. So its corresponding activity name is H and time duration from 5 to 8 is 2. Okay. Then draw a path between 6 and 8. Its corresponding time duration value is 5. Then draw a path between 7 and 9. 7 and 9. Its activity name is J and corresponding time duration value is 6. Then the last thing, draw a path between 8 and 9. 8 and 9. Its activity name is K and corresponding time duration value is 4. So this is what the network diagram for the given activities and duration values. Okay, hereafter we are going to find the critical path. The critical path. How many possible ways from 1 to 9? Yes, what are they? They are 1 to 2, 2 to 5, 5 to 8, 8 to 9. It is a first path. Then second possible way is 1 to 3, 3 to 6, 6 to 8, 8 to 9. Then another possible way is 1 to 4, 4 to 7, 7 to 8, 7 to 7 to 9. So these are all the possible ways to complete a project. To complete a project. So path 1, time value for path 1 is 5 plus 5 plus 2 plus 4. It is 16 weeks. Then time duration value for path 2 is 6 plus 7 plus 5 plus 4. That is the way is 1 to 3, 3 to 6, 6 to 8, 8 to 9. And we have to add, all these activities corresponding time duration value. So 6 plus 7 plus 5 plus 4, it is 22 weeks. 22 weeks. Then the third path is 1 to 3, 3 to 7, 7 to 9, 7 to 9. Its corresponding time duration value, is 6 plus 10 plus 6. 6 plus 10 plus 6. It is then path 4. Path 4. Path 4. It is also starts from 1, 1 to 4, 4 to 7, 7 to 9. 7 to 9. So its corresponding time duration values are 3 plus 4 plus 6. So 13 weeks. 13 weeks. Okay. So compare the time for the 4 parts. Why? Because means we now we are going to find the critical path and its time duration value. So definition for the critical path is longest time duration value of a project. Okay, so we have to find the maximum of time duration, maximum of time values for all the 4 parts. That is maximum of 16, 22, 16, 13. It is 22. So we see that the following path has the maximum time, so that it is the critical path. It is path 2. Path 2. 1 to 3, 3 to 6, 6 to 8, 8 to 9. Okay. 8 to 9. Therefore, its corresponding activity names are B, E, I, and K. I and K. So, rest of the activities, that is A, C, D, F, G, H, and J are called non-critical activities. Okay, so the project completion time is 22 weeks. 22 weeks. That's it. Here they have given, yes. So you have to find project completion time using the duration values, time duration values. So what's there in the sum up means you are able to understand how to find or how to calculate the project completion time using given time duration values. Yes, using time duration values. Then one keyword has been given. Keywords are CPM. CPM means a critical path method, as we all know that, and path. Path means a continuous sequence consisting of nodes and activities. Continuous sequence consisting of nodes and activities, and in that path, beginning with the start event and stopping at the end event. Stopping at the end event of a network. It is called a path in the network. path in the network. Okay, and hereafter we have given some terminal questions for you. It is explain the terms critical path and critical activities. As you all know that the critical activities and critical path. And the second problem is the following are the time estimates and precedence relationships of the activities in a project network. By using these given data, so you have to draw a project network diagram and also find critical path and the project completion time. The project completion time. Okay, so we'll catch you in the next unit. Thank you.